Okay, let's try to sum up what does quantum mechanical model of an atom says. What are the important features in it? So what is quantum mechanical model? It's a model of an atom which is based on the Schrodinger's wave equation, which believes that atom has wave function, and because of that, we are able to describe how are electrons distributed inside an atom. The first point says that when an electron is inside an atom's revolving around the nucleus, the energy possessed by it is quantized. That means the energy of an electron is quantized. That means it cannot have any value. It should have some specific value. Only some specific value or amount of energy is allowed when an electron is staying in an atom. Right? Those energies may be E1, E2, E3. I'm just denoting some, I'm just using some symbols, not giving the value, but it will have some specific value. The energy of the electrons is quantized. That means it will have some certain specific values. So the electrons are why they have quantized energy, because the electrons are behaving like a wave. And what helps to describe to get out to take out or to extract all the information. It's a Schrodinger's equation which helps in extracting all the information about the electron. This is Schrodinger's wave equation. This is this is called H is a mathematical operator, also known as Hamiltonian. Psi is the atomic orbital or wave function of the electron, and E is the energy possessed by that electron. So this equation it will be used to solve everything about an electron, right? We have an electron, and we'll according to its energy, the allowed energy, this equation will solve, and we'll get the well, then we got a lot of quantum numbers to solve it, which becomes a natural solution. Which are natural solutions uh, required to solving in this equation to solve this equation. So this symbol psi it denotes the wave-like properties of the electron. The third point says that it is impossible to determine both the position and the velocity or momentum of an electron simultaneously. That is called Heisenberg's uncertainty principle. And mathematical form expression of it is given by this. This is uncertainty in position multiplied by uncertainty in momentum will always be less than or greater than equal to h by 4 pi. It's a Planck's constant having value 6.626 into 10 to the power minus 34 joules per second, and 4 pi. This is a very small value, right? The product of it, the, the uncertainty in position multiplied and uncertainty in momentum will be more than or equal to this. So these are inversely proportional. So what does it mean? That if its value is more, it will be less. If it is less, it will be more. Like if there is less uncertainty in position, there will be more uncertainty in momentum. The more you try to, that means the more you try to find out the position of an electron accurately, there will be more error or uncertainty in its momentum or its velocity, because momentum is again the product of mass and velocity. What is X here? It's the part. That means, what does it mean? It means that since you're not able to determine the position, it means that you're not able to find out the exact path of the electron around the nucleus. So that means path can never be determined accurately. That's what is written here. So what the wave function of electron is denoted by psi. What is that? What does it contain? It contains all the information of the electron. And an electron can have many wave function or many orbital wave function in an atom. For every wave function, it means the amount of energy it will have. That means the position, the space where the electron can be found will be many according to the wave function it has. So we say that the space, the wave function, it's also known as atomic orbital. It somehow is related to the space around the nucleus. So, and we said that, and that is called orbital, right? Orbital is not orbit. It's a orbital means a space around the electron, space around the nucleus where there's a maximum probability of finding an electron. So there are many orbitals in an atom, but each orbital will have this box determines one orbital, and each orbital will have only two electrons in maximum. There will be many orbitals. There will, depending on the wave function relevant or concerned with it, but each orbital will have only two electrons. And the wave function, the orbital wave function of an electron contains all the information about the electron, and this will be extracted through quantum mechanics. So quantum mechanics helps us in extracting all the information about an electron from the wave function it possesses, from its wave character, right? All the information means where it will be, how much energy it will possess, right? These are the information that can be extracted from the wave function through quantum mechanics or through this mathematical equation, Schrodinger's mathematical equation. Although the atomic orbital of an electron doesn't have any physical significance, the wave function doesn't have it's just a number, doesn't have any physical significance, but the square of it, the square of the orbital wave function, it gives us the probability of density, which gives the probability density means it gives us the probability of finding an electron at that point in an atom. This is what this orbital wave function, the square of it gives the probability of density at a point. That means what is the probability of finding, the value of this will give what is the probability of finding an electron at this particular point around the nucleus in an atom. Hope this is somewhat clear.